Hi! Today we're going to learn about applications of quadratic equations. Let's say we have a problem like this. Find the range of values for which p, for which the line x minus 2y equals p never meets the curve x times x minus y plus 8 equals 0. So, before we get started, let's figure out what we have here. We have a line x minus 2y equals p, and we also have a curve which is x times x minus y plus 8 equals 0. So here, when we have x minus 2y equals p, we can just translate this into, by adding 2y to both sides, x is equal to p plus 2y. So now we can use the method of substitution to substitute the value of x in for x. So p plus 2y times p, which is this x, which is p plus 2y minus y. And 2y minus y, as we know, is just y. So p plus y plus 8 equals 0. So let's combine this part. So we have p times p is p squared. P times y is py. 2y times p is 2py. And 2y times y is y squared plus 8 equals 0. So now let's rearrange this and let's combine like terms. So we're going to put y as the a term because we know that in the quadratic equation, which is x squared plus x plus c, which is the constant term, equals 0. The x squared goes first because x is the variable and it's squared, and so the highest degree goes first. And here, p is actually not a variable. For at one instance, or for that range of values, p is a constant term. However, y would be a variable that keeps changing along with the graph. So, we put y squared first, plus the coefficient of just y, so py plus 2y is plus 3y, plus the constant term, which is p squared plus 8. Plus 8 equals 0. So now let's take a look at this problem again. So we know that this line never meets the curve. We also know that if the line never meets the curve, so we have this line, and it never meets the curve, then that means that the discriminant has to be less than 0. Because for this example, when you find the value of y, that would make this like the x-axis. So, that means that in this example, the discriminant of this quadratic equation is less than 0. So, let's find the discriminant of this. The discriminant is b squared minus 4ac. So this would become b squared, so 3py so it would become 3py squared. So because it's just b, which is just 3p, it would become 3p squared, which is 9p squared, minus 4 times a, which is just 1, times c, which is p squared plus 8. So this becomes 9p squared minus 4 times 1 is 4. 4 times p squared would become 4p squared. And this is actually negative 4 because negative 4 times 1 is negative 4. Negative 4p times p squared is negative 4p squared. Negative 4 times 8 is minus 32. Is less than 0. So now let's combine like terms. 9p squared minus 4p squared is 5p squared minus 32 is less than 0. So that means that 5p squared is less than 32, making p squared, we're going to go this way now, p squared equal to 6 2/5, which is 6.4. So p squared is less than 6.4, making p less than the square root of 6.4 is making p less than the square root of 6.4 and greater than negative square root of 6.4. So the answer to this problem is negative square root 6.4. P is greater than negative square root 6.4 and less than the square root of 6.4. Today we learned about applications of quadratic equations.